They say the house always wins, but let me tell you a secret. I've heard of a way to guarantee you can win at the casino. It doesn't involve counting cards or special cameras, just simple maths. So first, let's go to the roulette table and place our bet, black or red. They spin the wheel and we see where the ball lands. And we have a 50-50 chance of winning, right? Well, here's the trick. Even if you lose, you can just try again, but with double the original bet. This means if you win that time, you win your original bet plus all of the money that you've lost. Lose again, just double the bet once more. Eventually, odds are you're going to win everything back.
Although it looks good on paper, in practice, actually, the bets can rapidly grow in size because you have this exponential growth, this doubling over time. And as a result, often the size of the bets can reach beyond what any gambler can afford, and indeed any casino could afford to pay out.
That voice of reason is Adam Kucharski. He's a lecturer in mathematics at the London School of Hygiene and Tropical Medicine. But I still think it sounds worth a try. Surely you'd have to be so unlucky to lose that many times in a row.
This technique, I think, really nicely illustrates how counterintuitive random events can be. Many people will think, well, actually, it's pretty unlikely that I'd lose that much money. If you start your bet on, say, £1, to lose £1,000, you'd need about 10 bets to go against you in a row. And for something like roulette, if you're betting on black and red, most people would think that's incredibly unlikely. But of course, it's those unlikely events that are possible, but perhaps we don't think they are, which can often have devastating results.
Maybe one to stay away from then. And I should probably trust Adam, as his book, The Perfect Bet, is exploring all the ways people are using science and maths to try and take the luck out of gambling, which in turn has led to some pretty big leaps in our understanding of statistics and probability.
Really, as far back as the Renaissance, people have used betting as almost a playground for ideas, for academics who want to understand how luck and randomness work. Gambling has been a perfect way of doing this. If you say roll 2 dice, how do you measure how likely it is you'll get, say, 2 sixes? That kind of question really motivated mathematicians to develop the theory of probability, these theories around how you can quantify how likely events are and look at expected outcomes. And really the development of that for the subsequent couple of hundred years, and even in the modern day, a lot of ideas are coming from people studying the games of chance. In particular, roulette was an example where people were wanting to know, is what I'm observing is random. So if you look at a large number of roulette spins and certain numbers come up, you want to be able to work out, is that a random event? How do I actually measure that? And Carl Pearson, who was one of the pioneers of statistics, used games like roulette to hone his techniques. And actually in modern science, we still use his ideas all the time. This concept of a hypothesis test. We have a theory that there's a pattern in a certain event or process, and we want to analyze the data to see if that pattern is real or whether it's just a chance outcome.
What Adam is referring to there is the p-value, something used by scientists all the time. It's used to work out how likely it is that the result is due to either the hypothesis being correct or a random fluke of chance. This is so important in deciding how much trust to place in any one result. So it seems I have roulette to thank for the long hours being forced to study statistics as an undergrad biologist. But roulette isn't the only form of gambling people are trying to beat with science.
Another area that people are working on is poker, so trying to create artificial players which can learn to play the game. One of the remarkable things actually with a lot of these bots is their creators, by their own admission, aren't very good poker players. So actually you've got these bots which have learned to play so well that they're far beyond what their creators are capable of. And in some instances, if you look at the behavior of these bots, they do things that we might think are inherently human. So they're very good at bluffing and manipulating opponents, and they can feign aggression.
How does a robot bluff? They're probably just algorithms, right? But I'm imagining a robot with sunglasses on trying to pretend it's got a good hand. How does that work? Do they play other humans?
These robots are essentially computer programs, and the way they train is to play games actually amongst versions of themselves. So these bots will play billions and billions of hands and learn to refine their techniques over time. Much like humans will learn with games of chance by making a decision, and if it goes badly, maybe having some element of regret and thinking, what if I'd done something differently? Would I have changed my decision? Would I have refined it? And the bots do something very similar. As they play these games, after every hand, they look back and think, could I have gained more or could I have done something differently to improve my strategy? And over billions of hands, these bots actually learn how to play the game and learn which tactics work better than others.
Very much enjoying the image of 4 robots sat around a poker table, maybe listening to some jazz, smoking some cigars. But can we take these advances outside of the casino into the real world, say the stock market?
Bots are actually appearing in finance as well, but unlike poker, where you have these bots which have learnt very complex strategies and really refined their techniques over billions and billions of games, in finance you have a slightly different problem. Because you want to trade quickly, you can't have a very complex algorithm because it just takes too long to run that computer software. And the problem if you have a very simple computer program is you can't include much rationality and nuance. In fact, as one researcher put it, you're not even at insect level intelligence when you have that simple an algorithm. So potentially, if you run into problems, the algorithms aren't well equipped to cope with it. And an instance a few years ago was a US stockbroker that had an algorithm to deal with customer orders. And in their software, they had a counter to keep track of how many trades had been made and make sure that they're not making too many buys or sells. But in updating their software, they installed these new counters on 7 of their servers, but not on the 8th. So in other words, the 8th was just running away and doing its own thing and making thousands and thousands of trades. And actually, by the time that they had actually worked out what was going on, shut it down, that runaway algorithm had been losing about $170,000 per second. And they've been losing per second for around 45 minutes. So that's hundreds of millions of pounds lost because you had this very simple, very quick algorithm without the ability to stop what it was doing.